This is not a course where I'm going to show you how every single thing is done. It's not about that. It's about understanding the real situation. It's about understanding how it's done in real life. I want to make sure you have all the knowledge to make sure when you are put in a real life environment, you know what to do, you know how it's done. And then we're going to continue with the cloud technology. This way, all your solutions are going to be deployed on cloud and they will be extremely robust. Guys, I look forward to seeing you in my course because it's going to be amazing. Please give me 5 minutes to explain you what this course has to offer. First of all, who is this for? This course is very well suited for sysadmins, developers, engineers, DevOps, and anybody who is interested in Docker and Kubernetes. After completing my course, you will have a full understanding how to write a fully optimized Docker image, how to deploy it to Kubernetes the right way, and you will know all the needed terminology of Docker and container ecosystem. We will avoid all unnecessary things that you won't use in your daily life and will get straight to knowledge to ensure that you know how to create, manage, update and deploy your Docker images on Kubernetes the right way. I will explain you what Docker and Kubernetes are and what technologies they came to replace. Just imagine how it was working before. Developers had to create virtual machines, install their software there, make sure it's running, and in the end of the day, they will hope it's not gonna crash. And that's just a terrible experience. In a chaotic workflow, when you're running multiple applications, it's not sustainable to manage them all. This is why Docker and Kubernetes came to life to make your life easier, so you can concentrate on things that actually matter, making your app more efficient and very well suited for your customers. Docker with Kubernetes just requires one file where you can define your server configuration. After that, Docker is going to build an image and that image will be deployed to Kubernetes, where Kubernetes is going to scale it up and down based on the demand. Main advantages of this technology and points that we will touch in this course. Deployments are made very seamless and secure. You can set up an automated and continuous integration pipeline where all your deployments are making to the cloud very securely and with the least effort. Scalability is seamless and automated. It can scale from 0 to 1000 instances in a matter of seconds, regionally and around the globe. Management of your server becomes effortless. All your configuration for your server is defined in a single file. Easy troubleshooting. No need to access your VM instance logs and try to figure out what's going on. Just access web UI based dashboard, local plugs, and solve your issues quickly. Enterprise grade security with isolated environments with secure configuration files and encrypted environment files that you're simply able to link to your workloads and use them in your application level. Stability is excellent thanks to advanced health checks and zonal and regional failovers. Additionally, we will cover more specialty topics with my tips and tricks. First of all, continuous integration. That's a key to success when working with Docker and Kubernetes. You want to make sure that your pipeline of continuous integration is properly set up. Let me just make an example. You're using GitHub for your source code repository. And when you're making that commit or pull request is being merged into staging or master branch, you want your code to be pushed to Google Cloud, where Google Cloud is gonna make that image. And Google Cloud will take that image, it will push it to Kubernetes, and Kubernetes is gonna update your server. So in short, whenever you're making a commit, the Google Cloud is gonna update your server. And this way, you don't need to worry about building image, deploying it. It's worry-free and it's amazing technology that we have to explore. Secondly, I'm going to show you how you can deploy React.js frontend on a Kubernetes workload. Afterwards, I'm going to show you how you can deploy Laravel application, and we will tackle all the needs of Laravel in order to make sure that it's so performance oriented whenever it's deployed on a Kubernetes. And lastly, we will deploy a Redis instance that we will connect to Laravel. I suggest any engineer and DevOps team leader to look into what potential this technology can bring to your project, to your team, to your company. It's phenomenal. Take your time to explore it. Server deployment is when application is made available on a long-running instance. It can be deployed locally with a static IP, however, it's not as sustainable. That is why many companies would deploy it on a cloud level, such as Google Cloud, AWS, Azure, and many other cloud hostings. We need multiple servers to handle higher workload. Imagine if a company has 1 million users. They will be running on multiple instances to ensure that their customers are not experiencing any interruption or lags. How deployment of server works without Docker and Kubernetes? The process is very painful. You would set up a virtual machine, you would connect to it in two different ways. First will be SSH. You would open your terminal, you would SSH to it, you will make sure that the private keys are matching so it will give you access. After that, you want to transfer your application files. You would open any FTP client such as FileZilla or other clients. You would transfer files from your computer to your server. After that, you would go in there from the SSH terminal, you will install your application files, you will install any other Linux dependencies that you might need, and after that, you will launch your application, and when all that is done, you will hope it's not crashing. And God forbid you need to launch an update, because if you do, you need to repeat the same process. And now imagine if you have hundreds of such instances. You need to connect to each instance, update or launch each instance individually, and go absolutely nuts about worrying of hundreds of things that might possibly go wrong. However, now the Docker and Kubernetes, they eliminate this issue because you're writing just one image, you're deploying one image, and Kubernetes takes care of the rest. Docker is a container concept that solves all the challenges. Dockerfile allows you to write all the configuration for your server, then build it, and after that is built, it's compiling it in an image. And this image you can seamlessly deploy to Kubernetes, where it's gonna run it as a server instance. Why do we need Docker? It improves scalability, it's so secure, it saves you so much time, and it's just amazing. You need to explore the course and you will know exactly why Docker is so great. Before we get started with the actual Docker, we need to ensure that we have a proper environment setup. I will be using PHP Storm IDE. I have created a separate project here, and I'm gonna go in here, press new, select a new file. I will make a new image, pretty much new file. I have called it Docker file, and this is where all magic begins. So please do the same and follow closely. It will be amazing. So what is Docker file? This is the file where we're gonna define what Linux you're gonna be using. Here we're gonna use your application files. We will expose IPs. This is the file where all the configuration for your server happens. So let's get started by installing the Docker. So you would go to Google and you would say install Docker. And here we will open the first page, and depending on your OS system, in my case, I have Mac, so I'm gonna press Docker the desktop for Mac. And here I'm gonna choose the Mac with Apple chip. If you have the old version of MacBook, you would select Mac with Intel chip. So here you can hit download, and it's gonna start installing the Docker locally. And you really need this because in order for Docker image to be able to build, for it to run, you need to have Docker installed on your computer. And after you are done, you should have the Docker app. And so here you go. After you have installed it, you should see this Docker desktop app. So let's get started. First thing you need to know that in this tutorial we're not gonna write our own Linux. Therefore, we need to extend it somewhere. So essentially, whether you're using CentOS Linux, using Alpine Linux, using Ubuntu, or any other software you would like to use, you can use it easily. So let me show you how we're gonna do it. We will use this command, it's called from. And from, we need to address some package. In this tutorial, I'm gonna address Alpine, and I'm gonna select the latest package. And you can ask me how I did it. Why Alpine? This is why Alpine. In this case, Docker Hub comes in very handy. So we're gonna go in to Google. You're gonna Google Docker Hub. Write this one. And here, as you see, they have multiple Linuxes. They have NGINX, they have MongoDB, Alpine, Node, Python, BusyBox, Ubuntu. So besides Linuxes, they have a lot of different softwares here. So let's explore the package that we need. It's Alpine, Linux, and you see they have multiple versions. So essentially I could go back and I say, you know what, I need this 3.14 version. You see it's already syncing with the Docker Hub. It's very handy. But essentially, I just want to take the latest package, so I'm just going to put in here latest. But let's say if you feel like using Ubuntu or something else, you could just go in here, look for Ubuntu, look out for official image. This is the official image of Ubuntu. As you can see, over 1 billion downloads. And right here, they have multiple different packages, but you could do something like this. You could just say Ubuntu latest and just choose it. But in our case, we will use Alpine, and I'm going to explain later why I made this decision to use Alpine Linux. Now I'm going to show you how to use another very handy command line. It's called environment. So here we can set up our environment files or environment variables. So let's say if you want to say that we would be using some special configuration path and you will use this path multiple times later, it's better to define it on top, because you don't want to rewrite the same thing multiple times, and let's say when you need to change it, you would go in file and change. So it's always good to define some things. So let's say in this case, I'm going to define a config path. I'm going to call config production. So in this case, I will make a folder. Here we're going to store our config later. So config production, this is done. And just making an example, let's say you're running some node and you need a specific version of a node. So you can do it this way. You can just define node version. You can say 11.11. You see, in this case, I can leave it just like that, or I can say equals. It doesn't matter. But what I was talking about is that here I'm defining node version, and later when you're going to install it, you can install this exact version. It's very handy for applications that need to support versionings, and this means that while the server is being built, it's choosing exact versions you need, and it's not going to break after. Again, this is another beauty of having your application in containers, in this case in Docker. Now I'm going to explain you about most exciting command that you're going to come along in Docker. And the command is called run. So what does it mean? So in this command, we will run Linux commands. So imagine that whenever you're logging into Linux, you can, let's say Ubuntu, right? You can install some packages by running apt-get install vim as an example, right? Or PHP 8 or npm and other packages. This is essentially what you will do here. You would say run, and then you would install the packages or run other commands that you need. So in Ubuntu you would say apt-get install. In CentOS you would say yum install. But in the package that we will use, Alpine Linux, we're gonna say apk add. Again, there are always some small details. In this case, I really want to say no cache because I don't want any images, anything to be cached in this particular purpose, not to come along some errors, bugs. So in this case, I'm going to say no cache, and I'm going to say add. And here you can start adding multiple packages, such as NGINX, PHP 8, or NPM, and so on. So in this case, really, I don't think it looks too good, because whenever you look at something, you want to have a clear sight of it. You want to make sure it's not kind of colliding into one information. This is why we can do the following. Just put this little slash in end and hit the next line. Again, put the next slash, hit the next line, put a slash, and so on. This way, you're really not gonna come along problem that you're not gonna understand what software packages you're installing. Everything is gonna be overviewable, and that's very important. Now we will be installing all the packages that you need in order to run our NGINX server. So we will start with NGINX is here, PHP. Then, since NGINX is going to be running PHP, I want to ensure I'm including all the PHP packages. And again, this is something you don't need to memorize, because look, it's not going to help you if you're going to memorize that you need to add PHP common, PHP CLI. So essentially, whatever we're doing right now, you can just keep it on your cheat sheet. Kind of write it down and keep it for future, because every time you will write a Docker file, you don't need to remember that you need to install PHP DOM or anything else. This is not the information you want to keep in your head. So let me install all the needed packages. So I just added all the PHP packages that we will need in order to run our NGINX server. So as you see, PHP CLI, FPM, DOM, MB string, and a couple of more packages. Again, some could be removed, but let's continue. Okay, and now let me walk you through each package that is good to have on a server, like wget. You always need it, because if you want to download some extra package, just better to have it on your server. Then unzip, it's always good to have. GCC, also recommended. It's a C++ package. bzip2, it's needed for zipping and unzipping files. Git, you will need this one for sure. OpenSSL, also needed in order to, that's needed for SSL certificates. Now we will add a curl. Curl is always a useful package. We'll add Vim. Let's say you want to connect to server later and edit some file just to explore it. It's always good to have this package. Supervisor. So for now, let's just add it. I'm going to explain it to you shortly why we are adding this package, and that's actually a very important reason for that. NPM, you might be very familiar with this package manager for Node and JavaScript, Node.js. And we will add the Python 3 and Python 3 developer tools. And really the Python will be used for supervisor, right? And here, since we are adding this whole separate section just for installing packages, it's always good to add some comment, because comment is gonna, whenever gonna go back to Docker file to overview what's happening here, we will know right away when you leave comments. So here I'm gonna say that we are installing packages. Okay. All right, and again, some packages could be removed, but from my experience making over than 100 different Docker files, I'm keeping my stack of packages that I know for sure they will be needed at some point. So I'm kind of keeping the stack more or less the same, but based whether it's a backend, I would include more packages, because as you know, backend could need more packages, such as some visual packages, lot of different stuff. But for this case, we are making really what we're gonna do. We will make NGINX server run a simple React JS application, so you will be able to deploy your front-end server on a Docker. So we are keeping it simple for now. So this is why these packages will be enough for this case. Alright, so we are done with installing all packages we need in order to run our Docker container, in order to create it essentially. And now since we installed npm package here, we would like to install some additional npm package. So we can do it in the following way. We just say run npm install. We're gonna say globally yarn and node gyp. Again, you can install more packages as you need based on your application, but in this case we will install these two packages, right? And now some tips and tricks, kind of stuff that you would really need. We need to make a symlink, so programs that function on PHP would know where's the PHP, and we do it the following way. And again, this is not something you need to know by heart. This is something you do it once and you can just repeat it later. And now all the programs that need PHP, they will know that they need to access this directory, because we are making a symlink. All right, and now now let's make the directory, our HTML directory, where we will put our application. So we will make a comment, make directories, and we're gonna run mkdir. Mkdir will, as the command says, it's gonna make directory. And we will say p and var www html. So now this command will make an empty directory at this location. And now we are about to start copying our application there. Alright, so let me introduce you to a very useful command that you will use a lot. It's called copy. So copy means that you're copying files from your local environment into the Docker image. So in this case, I have added a couple of files: fcmpool, nginxconf, php.ini, supervisor.conf. So these files, please download them from the tutorial and paste them in here. Of course, I'm going to walk you through these files. So first one, fpmpool. This is something that's needed for nginx. Again, you can go in deeper here and adjust the values, but at this time they're very optimized and there's really no need to adjust them. Next one is nginxconf. This is the most important configuration that you could have. So here we are really defining HTTP server. Right here, these are really basic things. So here we are telling server, hey, listen to 8443 SSL port. Name of the server is going to be ctomentorship.com, and you can go and find SSL certificates at these locations. And we are setting some SSL cache. We are saying where's the root at this location, HTML. System needs to look for index.html file. So as you see, it can try multiple files. I'm telling him explicitly, look for index.html, so it would not waste time and resources. And a couple of more things here, such as gzip and so on. Then we have php.ini. This is a file that I have compiled throughout the years of my experience. We will be using this file. And supervisor configuration. I'm going to walk you through this a little bit later as well, but in short, this is a program that's essentially is managing tasks. So you're telling it, hey, let's look at this here. Hey, run this command NGINX daemon off. This is how you will run the server. Run it under user NGINX. You put all the logs here and a couple of more options. And these are really the default things that you would have there. And we will be using these files. So let's continue. So we will be copying each of these configurations. So let's start with selecting that directory where we're getting logs, where we're getting our configuration files from. We will say copy configuration supervisor conf to this particular directory, supervisor conf, and this is really the default directory where supervisor is expecting to have a file there. Then we will continue with NGINX configuration. We will put it to this location, NGINX, and NGINX configuration. Then we will copy FCM pool and to this particular location. Again, as you see, the location is a bit confusing, right? But you don't need to remember this exact path. You can just keep it in your cheat sheet and use it later as you're creating more images. So now we are copying PHP ini as well into another bit confusing directory. So this is where PHP 8 will know to look for PHP ini. And then here we want to put a comment where we're going to say that configs. So essentially, when you're looking at this location, you will know that, hey, at this location, I'm really transferring my config files. And let's add one more file. It's very important. I'm going to call it entry point. So let's create this file, entry point, and we will keep it simple. So first, let's define on top that this is sh, like shell environment. All right, sh, and you could write multiple shell commands because this is something that's going to be executed when the container is launched, and it's very handy to keep the right architecture in place. So whenever you need to put something here, you could do it, but in this particular case, we won't. We will keep it simple. We're just going to say execute the pretty much parameter that you're passing here. And now let's go back and transfer your entry point to Docker. And we will do it in the following way. First of all, let's put a comment that we are transferring entry point. Very important. Okay, so we will say copy config production entry point and entry point.sh. Okay. Let's discuss permissions, because permissions are a very important part of any server, any environment, because we want to ensure that whenever your program is running, it has access only to the files that you need, and by no means it won't have access to the root files, because it could be a big security breach. So let's go into here and define the owner of these files. So in this case, since we have NGINX web server running, so we will do the following. We will say chown equals NGINX right here, and after that we will define that this file is executable, and we do the following. So we are saying run chmod putting plus x. It says that the file can be executed, and we are saying that this entry point sh can be executed. And And now we want to set the permissions to our HTML folder and a couple of more folders. So let's do the following. We will say that we are setting permissions right here. Even if it's complicated, whenever you're leaving comments, you see it looks really clear, and it's a good practice. Okay, so now let's say run chown. We're gonna say recursive to all folders inside. So NGINX, and we will say var www HTML. We will add. See, we are adding a couple of more commands here, and here we are making a new break line. We'll say chown, same thing, NGINX to run. We will do the same thing one more time, and var lib NGINX, and this again the new line chown r NGINX. And again, if you feel like you don't know what's happening here exactly when we set these permissions, it's fine. You don't need to know A to Z how the permissions work. You just need to understand that we are setting this user group for these files, so NGINX could access them, and it won't be able to access anything else. That's really the main, most important part you need to understand. And very important part about the permissions also. While you're starting to run your Docker container, right from the top, it's assuming that you're a root user, right? And you can really execute any commands, such as right here, we executed chmod.h. Really, only root can do it. This is why I'm telling you, Beaver acting as a root. But at the moment when you are done with installing packages and all the things that you would do as a root user, we can do the following. We can just switch. See this? Okay, let's go here. Let's remove this slash. So we can do the following. We can switch to non-root user, and it's a good practice to do so. All right, and we can do it the following way. You say user NGINX, all right? And for Apache, it would be something like www data, but in this case, it's NGINX, all right? And now, next tutorial, we will create React.js front-end files, and we will start building them, setting proper permissions, and deploying our container.